is teacher Jackson Ibarra of Cabatagan National High School in the service of Lanao del Norte in providing quality education amidst pandemic. This lesson has many activities that will help you define operations and functions. Identify the different operations and functions, perform addition, subtraction, multiplication, division, and composition of functions. Before we'll start, please answer the pre-test in what I know. This test will determine your prior knowledge about this lesson. You are given 10 minutes to do this. Good luck! Great job! Today, we are going to learn operations and functions. Operations and functions are similar to operations and numbers. Adding, subtracting, multiplying, and dividing two or more functions will result to another functions. To be fully equipped in this lesson, you have to recall how to add, subtract, multiply, and divide algebraic expressions, and how to evaluate functions. To do that, please answer the activity in what's in the secret message. Answer each question by matching column A with column B. Write the letter of the correct answer on the space provided. Decode the secret message by filling in the letter on the corresponding item. You are given 10 minutes to do this activity. Your time starts now. Let's start this lesson with this activity. Read carefully the situation and answer the question below in what's new. Awesome! This time, you had already known that some situation can be represented by functions. Let's take the examples in the situation earlier. Nea can be represented as f of x is equal to 5x plus 10, and for Noah's savings can be represented as g of x is equal to 3x plus 5. Combining Nea and Nea's piggy bank will result to another piggy bank, which is h of x is equal to 8x plus 15, where x is the number of days and 15 is their constant saving. Operations and functions can be written in different forms. Let us consider letters f and g as functions. Their sum, denoted by f plus g of x, is the function denoted by f of x plus g of x. Their difference, denoted by f minus g, is the function denoted by f of x minus g of x. Their product, denoted by f times g, is defined as f of x times g of x. And lastly, their quotient is defined as f over g of x is equal to f of x over g of x. Let us consider this example. Given the functions f of x is equal to x plus 5, g of x is equal to 2x minus 1, and h of x is equal to 2x squared plus 9x minus 15. Find the following functions. Letter A, f plus g of x. Letter B, f minus g of x. Letter C, f times g of x. And letter D, h divided by g of x. Here's the way on how to find for the sum of the two functions. Let's say, what is the sum of the two functions f of g of x? So, we all know that the f plus g of x can be written as f of x plus g of x. Since we know that f of x is equal to x plus 5 and g of x is equal to 2x minus 1, we can substitute the value of the f of x and the g of x into the given equation. Therefore, f of x can be substituted by x plus 5 and the g of x can be substituted by 2x minus 1. To add algebraic terms, we have to remember that we can only add terms if they are similar. And we can say that the terms are similar if they have the same literal coefficient and exponent. So let's say x plus 5, we can remove the parentheses, x plus 5 plus 2x minus 1. So what is the sum of x and 2x? Since these are similar terms. So in adding similar terms, we just add the numerical coefficient. This is understood as 1 and 2x. So what's the sum of x and 2x? That is equal to 3x. And the sum of 5 plus the negative 1 is equal to 4. So therefore, the sum of the two functions, f plus g of x, is equal to 3x plus 4. For letter B, we are going to find for the difference of the two functions, f and g of x. And we all know that f minus g of x can be written in the form of f of x minus g of x. Since the function of x is equal to x plus 5, and the function of g of x is equal to 2x minus 1, we can substitute the values of f of x and g of x into the equation. And that becomes x plus 5 minus 2x minus 1. Now we are going to apply the rule of subtracting integers in this case. And we all know that in subtracting integers, we have to change the sign of the subtrahend and proceed to addition. This becomes x plus 5 minus 2x plus 1. Okay, so we're going to change here from positive, we change that one to negative 2x. From negative 1, we're going to change that one to positive 1 and proceed to addition. And this becomes x plus 5 minus 2x plus 1. Since we have similar terms here, x and negative 2x, we can combine the two. And that becomes x minus 2x is negative x. Positive 5 plus 1 is equal to positive 6. It means to say that the difference of the two functions f and g of x is equal to the negative x plus 6. And for letter C, we are going to find for the product the two functions f of x and the g of x. Since we know that the f times g of x can be written in the form of f of x times g of x. And we know that the f of x is x plus 5 and the g of x is equal to 2x minus 1. We can substitute the values of the functions f and the functions g. And that the f of x is equal to x plus 5 times the g of x is 2x minus 1. Now we are going to apply multiplication of binomials. So we are going to multiply x and 2x, followed by multiplication of x and negative 1. So we have here x times 2x, that becomes 2x squared. X times negative 1 is equal to negative x. And let's proceed to multiplying 5 to 2x and 5 to negative 1. So what is the product of 5 times 2x? That is 10x. And what is the product of 5 and negative 1? It's negative 5. And can you find some similar terms in here? Yes, there is. Negative x and 10x. So what's the sum of negative x and 10x? That is 2x squared, negative x plus 10x is equal to positive 9x minus 5. So therefore, the product of the two functions f and g of x is equal to 2x squared plus 9x minus 5. For letter D, this is quite difficult compared to the examples A, B, and C. In here, we are going to apply the concept of simplifying rational equations. Here, h over g of x can be written in the form of h of x over the g of x. Since h of x is equal to 2x squared plus 9x minus 5, and the g of x is equal to 2x minus 1, this becomes 2x squared plus 9x minus 5 over 2x minus 1. And how can we divide quadratic equation by a linear equation? And the answer is we are going to apply the concept of simplifying rational equations. For us to do that, we are going to factor out 2x squared plus 9x minus 5, and that becomes x plus 5 times 2x minus 1. If we are going to get the product of this, we will come into 2x squared plus 9x minus 5. That is over 2x minus 1. Now, can you find the same binomial in the numerator and denominator? Yes, there is. And that binomial is equal to 2x minus 1. And the denominator also has a binomial of 2x minus 1. So therefore, we can figure it out as 1. Since a number divided by the same number is equal to 1. So the remaining expression is x plus 5. So this means that the quotient of the two functions h and g of x is equal to x plus 5. To master the skills that we have learned today, please answer the activities in What's More, Activity 1, Matching Functions, and Activity 2, Let's Simplify. You are given another 15 minutes to do this. Good luck! To sum up what you have learned today, complete the table below in what I have learned. Write your own definition and step of each operation. To deepen your understanding about operations and functions, please answer the activities on what I can do and the assessment. Write your answer in your activity notebook. You are given 20 minutes to do this activity. That's the end of our video lesson for today. My name is Teacher Chasa Ibarra, your General Mathematics teacher on air. Stay tuned on LTN TV for more video lessons. Have a great day!